Hello and welcome to this session of our video series. Um, I was thinking let's spice things up. So far, if we look back, we have created this REST application. We have made it available to uh, add employee, update employee, retrieve employee, give us a list of employees, or even remove an employee. So far so good. And basically, we have put it in the GitHub, and now it is version controlled. It is all good. So I was wondering if we can spice things up now and run this application in a container. So let me explain this a little bit. But before that, I expect you to know the Docker and all these things. This is not a course training Docker and all. It's just basically a progression of creating an enterprise application. We don't go through the nitty-gritty things over here. Sometimes we don't have a choice and we have to dig in, but most likely, uh, if something happens, you know, and if it's an error, sometimes I actually know what I'm doing and I create that intentionally to show you how to resolve it. And in this session, we're going to do the same thing probably. So let's play it by ear and see how things go. We are not unfamiliar with Docker images. We downloaded a Postgres Docker image and ran it in a container. So, and it is right here in the Docker desktop. We have already gone over this when we were installing database. So, but I tell you quickly that this is basically we have an image of Postgres and then we run it in a container. So what is it? What is the relationship between an image and a container? Basically, you can create many containers from the same image. Image is a blueprint, okay? And so that said, right now this container is basically we have to start it uh, to work. And how do we start that? We use Docker. Over here, we can right now it's stopped. We can in the Docker task, we can desktop, we can go and click this. But it's a good idea, to familiarize yourself with the Docker commands. So instead of that, we can just go to git bash and say Docker run and run it in the detach mode and run this, for example, map it to port 8080, map or application port to container port 8080. And what is our container name? Okay, the container name is Postgres demo. So Postgres demo. Um, so all right, it's saying that it can't find the Postgres um, latest version of that. It's because basically I typed it wrongly. It's Postgres, not Postgre. So I'm going to go ahead and correct that. Okay, it says that we have another error, unable to find image Postgres demo. Okay, so it's expecting us to actually um, run an image, but we want to start a container. Those are two different things, and that makes sense. So what it means is that we can run an image, but we have to start a container. So that's very important distinction. If you go to the image tags or you instead type in Docker images, we have this image name over here, Postgres latest. If you run that, it creates a new container over here and gives it a different container ID. Okay, but we already have a container. How do we know? If you execute, let me get a clean. Okay, if we say Docker ps. Right now there is no container running, but if we say docker ps -a, you see this container is running. This container exists, but it's not running. Basically, it's exited the status. And the name of the container is Postgres demo. So, so we can start this container with the start command. But if you want to create a container from an image, then you use the run command that we use. So over here, let me show you exactly what I mean. If over here I have this and I have my image name as Postgres, so what I can do over here, I say that. So it's going to create a container, and I can even give the container a name. Okay, I can say the name of this container, let's name it Postgres 2. Okay, and now if I do this, now we have a new container from the same image. So if I go over here in the containers, see, I have a container demo, I have a Postgres 2. These are two containers. We just need that one. We don't need two containers. So let me remove that. So we are getting familiar with the Docker commands over here. So there are many ways of doing it, but let's do this. Docker rm, that means remove, and then the container name, which over here is Postgres 2. When I do that, you see it was removed and it just echoed the name of the container. That's a confirmation. So now we have this container Postgres demo. We want to start it. So we say docker start. Okay, Postgres demo. That means the container is started. You see this turn green over here? The container is running now. So wonderful. And one way of actually verifying that what's going on in the container, we can look at the container logs if there is any. So we can over here say docker logs and the container name, Postgres demo. Oh well, see, there are logs over here, and that means that it has started and listening on port 5432. Wonderful. So let's clear this. And now we want to actually create a container for our application. So if we want to do that for any application that we want to create a container, in the root of the application, we have to create a Docker file. So let's create that Docker file. We say new file, and we call it a Docker file. This Docker file doesn't have any extension. It starts with capital D, and the rest of the letters are lowercase. And yeah, we can add it because we are going to submit this to our Git repository. Okay, so we are at this predicament now that we have this Docker file, and wonderful. So what goes into this Docker file is the instructions for the Docker as to how to create the image. So basically Docker files has a from at a bare minimum, a copy, and an entry point. All right. And the from is the base image. That means what we're going to build this container, what this container is going to run on. Is the basically is it is not the operating system itself. It's not the usually it's a Linux file system that we want to use, and for that we have to add an image over here. So what image do we need? We need actually a Linux environment where our application runs in it. And that Linux environment, basically, that our application runs in it, needs a JRE to run our application. if we want to build our application via this like Docker file, we need that Linux environment to have actually the Java JDK. But we are not going to complicate this. We are going to build it locally and then create an image from that local build. So how are we going to create, what do we need for this? Let's um, I can create another issue. I don't want this video to be too long, but it is very helpful actually what we are going to do now. So let's go to the Docker Hub. I'll show you how to. Docker Hub is a repository of images. Okay, you can easily create an account over there and sign in. Right now we don't need to sign in, and but here we go. Uh, Imagine that we want to run Java 7, JRE 17, for example, something like that. So you see, all these things come up with JRE 17. These are images, most likely Linux images that have JDK 17 in them. But um, and we particularly interested, for example, in uh, Ubuntu kind of like image. So Ubuntu is a lightweight version of Linux. So you come over here and you see we have all kind of information about this image, what is it and all. And there are some instructions as to how to basically run it. So, um, but what it's saying over here is that uh, this Ubuntu doesn't come with the JDK 17. It basically, you have to install things on it. It's empty. See, once you basically put it in the Docker file, you have to have a run command to actually install what you need on it, and that we don't need. We need an image that comes itself with JRE, and I have already researched this, and I found a good one. But for the purpose of testing, I'm going to say, okay, find me an Ubuntu. Let me see. This one, does it have any Java or JRE? No. Let me go back up here and look for Ubuntu with Ubuntu with JRE. Okay, so you see over here we have Ubuntu JRE. Wonderful, and let's use it. So how do we use this? Let's just scroll down, and okay, it says over here all you have to do is do this. And but we don't. This is also for building the application. We just need to environment to run it. So let's go with this. How about that? So this is our base image. Uh, Okay, what does this copy mean? Copy means take whatever is in the target folder. So what do we have in the target folder of this app? We need to take this jar file, right? This jar file. And why do we need that? We need that. Well, let me take a step back. We need if we want to, we don't have to just run. We can run this application using clicking this. We can go over here, as I already told you, to this main entry point. Over here, this employee applications, right click it and run it. There is another way of doing this, and you can actually go to the target folder of this application and say Java, I'm sorry, down here, say for example Java minus jar and then target and then the name of this jar file. If I can say jar, it doesn't like it. So let's use Java is not recognized. Oh, okay. So looks like we need to configure this. But basically, this command is used to run this jar file. and this is one way of running it. But this is not configured actually. This um, um, terminal to use Java yet. Let me see. Can I, just for the purpose of testing, uh, Java is not here either. So um, okay, let me see if I have the Java installed local, because we are using the Java version that is bundled with um, IntelliJ. We don't have it on the path. I don't have Java installed on my machine, and so let's for now bypass this test. But you can take my word for it that this runs the jar file and creates this. It's just like running it locally. Um, so uh, we need this application. We need this to actually um, uh, when the Docker starts, run this command for us. Run exactly the same thing. So let's put it there. Um, but what is going to be the name of the jar file? The name of the jar file is pretty long. Okay, so let's abbreviate that. We say Java is the first command, and then uh, dash jar is the argument, and then let's call it this app.jar. How about that? So, and over here in the copy, what does copy means? Copy means take whatever is in the target folder. So target anything.jar, which is only just one jar, as you can see over there, and copy it to the working directory. But we didn't specify the working directory. So let me take a step back and specify that work dir is the directory on this Ubuntu that we are going to install and run the application from. And usually by convention is this app. Okay, so the copy means take this jar file from here and put it in that directory. Okay, but once we do this, once we execute this, we are already in that directory. So we are saying, okay, put it in this, copy it from everything that is jar from this target directory, and copy that to app.jar. Okay, and now the entry point will be Java minus jar, and that I'm not sure. I'm getting an error message here. I'm not sure what that is for. Okay, so okay, yep. So that's what we are missing. Let's add that. Expose. Yeah, expose port 8080. Expose port 8080. Yeah. So that means that this container is going to run on port 8080. All right. I think there is a formatting issue. Let's see. Yeah. There, we are getting this error because of this. Okay. Looks good now. Okay. So at the bare bone, we need from, work dir, copy, expose, and entry point. As I told you, this is not about um, uh, we don't have this tutorial about the Docker. We are just going to basically do mm, something that's related to creating an enterprise application, something that you deal with on daily basis, and this is part of it. So we have this Docker file. This is instructions to Docker as to how to create this image. So it's going to create this image by downloading this Ubuntu that has this JRE in it, and it's going to um, um, put this image has an Ubuntu Unix system, Unix environment. It doesn't have the Unix kernel, and then what's going to happen? The Unix kernel is going to come from our WSL2 that we installed earlier. and um, uh, it's going to basically choose the this directory, app directory on Ubuntu, to put the changes to put to as a working directory. So from now on, whatever execute a command execute after that is going to be executed in this app directory. So we take the target and put it in app dir. Actually, since we are in that directory already, we don't need to we need to put this on. Yeah, it's just the target is the same directory as our Docker file here. You see, and then we expose port 8080 from our container, and we run this command to run our application. So so what happens now? We are going to run the jar file, and the entry point for the jar file, as we know, this is employee application, which it's going to hit the main method, and it's going to execute a start or application. Okay, wonderful. So before we do this, as before, we need to make sure that, as I explained, the server, the database is running. Okay, database is running. Now we come down here to the to this yeah, over here, and we say docker build. That's the command. Docker build. What do we want to build? We want to build this image, right? And we want to give it what is the name of this image? So that name of this image or tag minus t is going to be whatever name we choose. How about emp image itself? And norm is to give it a version, okay, so that we can identify them. Or for example, if one version has been deployed that has some issues in it, we quickly revert back to the previous version while we are working on the issue. So and then where is this Docker file? The Docker file for this is in the current directory. That's here. So let's build this image. Okay, what's it doing is that it's downloading Ubuntu and basically creating our image. So if you go to the Docker file over here and you go to image tab, you actually see this. See emp image? It was created 14 seconds ago. Okay, and it's the version 1. Okay, so wonderful. And this is what we wanted. We can create another one like this and call it version 2. See, if we come up here, now we have version 2. There is another way of identifying these things. We can say, let me make this bigger. We can say, how about clear this? We can say Docker images. And now you see that we have EMP image v1, EMP image v2. Since we don't need image v2 and it's confusing, let's remove it. We can say Docker because v1 is v2 is obviously a copy of v1, so that would be confusing. We need to remove it. We say rmi remove image and then emp image v2. So it was removed. And now what we see over here, now if we say Docker images, we don't have image. We don't have the second version over there. All right. So just to have a clean thing, how about we also remove this this hello world image and say rm docker rmi, copy that and paste it over there, and we untag that too. All right, wonderful. So now we have two images, one for our Postgres, one for employee image. Be careful not to, with Postgres, we don't want to deploy, remove that. So how many containers do we have now? Let's check that. And we say Docker, and then PS There is just one Docker now, one container now. Okay, wonderful. And how many running? This is the container that's running, but how many containers do we have overall? Is we say ps minus a. We just have Postgres demo. This is wonderful. That's what we need. Let's stick with it. So, and the status is running. See, this container Postgres is running. That's what we want. Okay, so we created our image from the for this application. Now we want to run a container for that image. How do we do that? We say docker run. Okay, we want to run it in detached mode. Okay, let's give it a good name to this docker. So we say, for example, how about emp um, container? How about that? emp container, and then it's going to be running on port 8080. So we map the our local computer port to port 8080, which is the container port. And what is the name of this image? Wasn't it AMP image? Okay, great. So let's run it and see what happens. I know it's gonna fail, but it's a lesson I'm trying to teach you. So unable to find EMP image latest. Okay, what we want to do is says that you forgot to give it the right tag. Okay, we added that image. You see, it was created because now we have a container ID over here. So let's go and see if it's running. Let's see what's the status of this image. Docker and then PS. Oops, it's not running. The only running container is Postgres demo. So what happened? There is one way to um, go about this. Look at the logs for this container. So we say docker logs and the container name over here, which is what? emp container. Oops, we had an issue. It's complaining about the Java version. So what's happening is that we compile this code with Java 17. Do you remember that? So if we go over here in the project's structure and we look at the um, SDKs, it was actually JDK 26. OpenJDK 26. That's what the version. That's what the path is. And this is complaining that this version that um, we are running is JDK 8, and you can't run a code that was compiled with JDK 26 on in a server that's running JDK 8. The other way around could work for backward compatibility, but this is failing. So what should we do? We don't have the right image. The best thing is that we stop the container, remove the container, and then remove this image, update our Docker file, and create a new image with the correct kind of like a running environment or JRE. So how do we do that? Is in that order. We say docker ps. I'm sorry, docker ps minus a. So we don't want this container anymore. Let's kill it. We say docker rm emp container. Okay. So it container was removed because we say confirmation here, no error messages. And now we're going to remove also the image. So docker rmi for image, we use the I too. And then we say emp container. But we have to give it the version too, right? Okay, I'm sorry, version 1. My bad. No such. Oh, No such. Oh, this is not the right name. I apologize. It was EMP image. All right. So we got that too. That means that it was deleted. That message. Okay, wonderful. Let's go back to our so as you can see, this is JRE8, and this won't work. Let's use something else. I have already the um, checked the Docker Hub and found this working the image base image that is going to work with our application. So this is going to be able to handle that. Well, what we are going to do now, we're going to go and build again. So I'm going to use the upper arrow instead of just typing and get back to that Docker build command. Wonderful. And I'm going to say employee image now. Uh, this is not image one because even though we deleted it, it may exist also still in the Docker Hub or image repository. So let's give it number 0.1.1, v1-1 or .1. And then let's build this. Now it's building this image with a different based image. Wonderful. So this image has been built. Now, how about uh, this? How about now running this image? So let's go back to the run command over here that we had. Yeah, same things, but the image actually the container. Yeah, this is the same container, and that's the right image. Yes. So we are going to run this now. And it said, okay, I'm running this for you. You have that container. And if you look over here to Docker desktop, we'll see that the employee image is there and the container image, it is not running. So what went wrong again? Let's clear this and resort to the logs to see what's going on. So we say Docker logs and the container name, which was emp container. Oops, see, we have an exception. It says connection refused. What connection is that? That's the, looks like it's a Postgres connection. So, and it says the localhost 5432 refused it. So, what was this connection fail? What does it mean? It means that, okay, our application came up in a container, right? And it's looking on that container to this port looking for Postgres, but Postgres is not running in the same container. Postgres is running on a different container, right? So it's not local to the container that is running our application. That's the issue. How do we resolve this issue? Is that we have to create a network, Docker network. We have to put these two containers in it, and then they can see each other via that network. How do we do that? That's very interesting. So first of all, we have to um, uh, basically put stop that container that is running, which is or a Postgres container, uh, and add it to create the network, add this Postgres container to that network, add also the other container right now that failed to the same network, and then run them. So uh, how do we do that? Let's first create the network. So clear this, and then we say Docker network create. Let's call this employee network. Okay. Network with the name employee ID already exists. Oh, okay, wonderful. We already created it. All right. So, uh, so and, now we want to add. We want to connect the network, the container that's running the Postgres to this network. Okay. So, Docker again, network connect. Um, Network connect. Okay. EMP network, and then uh, what is the name of that container that we want? Postgres demo. Hopefully I did that. How do we verify that we Postgres demo now is in the same container? We say okay, Docker network and Docker inspect Postgres demo. Okay, over here we should have a networking tab. Yeah, and this and under this networks we have employee network right there. Wonderful. So now we can start the container, and we say for the sake of speed, now instead of just typing all the time, let's go ahead and didn't I stop the Postgres? I never did, right? Did I? Well, looks like now we have joined it to that. And let me see. Docker logs. No, I never. I actually created the network, and then I added that to the network. It's interesting that now, even though I didn't stop it, it joined to this network automatically when it was running. So wonderful. We can't complain about that. Now let's um, connect the other container that we have, which is EMP container to this network. Okay, let's now inspect this container to make sure that uh, that's also connected to the network. Yeah, it is. Look over here. Wonderful. Now let's start the container now, and since they are in the same network, hoping that they find each other. And we won't have that error message anymore. So yeah, docker run command. That was the one. Yeah, let's execute it now. What is that? Uh, what did it say? EMP is already used by container EMP container. Docker run. Oh, okay. It says Docker already exists. Okay, we can't run it, so we have to start it. Oh, wonderful. So Docker start EMP container. Okay, it started, and let's hope that it went fine. Oops, it hasn't been started. And let's go and find out what's going on. See over here, it says exited 7 seconds ago. Okay, let's find out what's going on with this again. So they are in the same network, but they still have, there is some issue. Let's go and find out what the issue may be. Okay, so we're gonna go to the logs, Docker logs, and then EMP container. Oops, what's going on? refactor unable to connect to local host. Oh, okay, same issue. Local host refused. So it didn't work. And uh, let's start the container now with a different approach. Okay, we have the container, and let's create a different container now, but we manually define what our connection information is. That should mold the issue. So clear, and let's remove that container. So we say, what was the name of the container? Docker, and then rm, then emp container. We want to create a new container now and call that new container, how about yeah, and let's also remove the image. Docker rm emp image v 1.1. Okay, it says no such image. Emp image. So where did it go? Docker images, emp image. Oh, I should have put rm I, not rm. Okay, now it's removed. Now we are going to create this image and run it, but with the information that we provide manually. And why do we do this? We want to make sure that we say, okay, the Postgres is running. We're going to explicitly say in this this is where it's running on this you have to connect to it via this container. Okay, so how do we identify that? I'm going to copy and paste some information here so I don't have to waste your time with that. This is the bash window. Okay, so emp image, and this is going to be dash 1.2. Okay, oops, sorry. And then the password is password. Yeah, everything looks good. The name of this is what we are going. The name of the database is empdb, and we're going to make sure that it understands it's running in this container. So instead of saying localhost 5432, we are saying Postgres demo 5432. And we are also specifying the network, EMP network over here. And the name of the container, yeah, okay. The name of the container is going to be EMP container. Unable to find image, EMP image. Oh, yeah, okay, this is actually V1. Okay, did everything go fine? Unable to find the image, EMP. Oh, I removed it, right? So let's build it again. That was a mistake. So it's very easy to build that one. We just go back to our build command. Yeah, it's building it again. Okay, now we're going to run that command. Okay, wonderful. You got the container ID over here. Now let's go and see if it is running. Docker ps. Okay, it is running. And let's go to the logs. See if you have a clean log without any error. So clear this, and I'm just going to be lazy and go to logs like that. Look, it's wonderful. You are getting the same thing that you used to get when we are running this. But I'm going to tell you what, we are not running the server over here. the Tomcat is not running here, and the Tomcat is actually running in the image or in the container. I apologize, and it is running uh, on the Ubuntu. I'm sorry, the server, the base image that we kind of over here um, chose to use. So, and very well. So how can we test this? I just to make sure that you believe that he's not running over here, I'm going to close this. Okay. And basically, I close the IntelliJ. You don't see the IntelliJ anymore. And I'm going to go ahead over here and uh, basically go to this here. And we had some employees over there, right? So if the server is down, we don't get anything. But if I change this from 6, for example, to 7 and call it, notice that the employee ID 7 came back. If I chose 5, notice that it's a different employee that came back. So this is Javed Yaramadi. Number 6, employee number 6 is Adam Smith. And employee number 7 is, again, Adam Smith. It has been inserted twice, looks like. Is this Adam Smith any different from the other one? Except for, no, this one is 41 years old. And we have two Adam Smiths. One of them is 40 and one of them is 41 years old. Wonderful. So I guess this concludes our demo. What we did over here was that we containerized our application and run it in Docker. We encountered some issue and when the application was trying to access the database and it couldn't connect to the database that was running on the same machine because the database didn't run in the same container. We put the database that was running in a different container under the same network. We created a Docker network, and put the same containers in that network. And we let the basically when running the container, let the application know how to access. Actually, call the container on port 5432 to access the Postgres database, and we tested it successfully. While we were doing this, we encountered some normal, regular issues that usually we encounter, and we overcome those issues. Some of these issues, most of them, they were meant to actually be created because they were lessons learned. I hope you enjoyed this. What I'm going to do in the next session, I'm going to push this image to the Docker Hub so that it will be accessible. I'm going to also save our changes into the GitHub so that all changes are saved in the repository as well. Thank you for sticking with me. I see you in the next video.